Question number 41. Find the equivalent resistance of the circuit shown in two figures between the points A and B. So here this point is A, this point is B. Here this point is A, this point is B. Now we consider first figure. So what do we observe? Here this resistance, this resistance, this resistance, this resistance, and this resistance forms a, these all four form a balanced bridge. So this resistance will be removed. So circuit will be like this. This will remain R, this R, and this R. And then this R and this R. So this is R, this is R, this is R, this is R. So R, 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 R. So it will be equivalent to one resistance R, this is 2R, this is 2R. And all three are in parallel. So 1 upon R parallel will be 1 upon R plus 1 upon 2R plus 1 upon 2R. So LCM will be 2R. So 2 plus 1 plus 1. This will be 4 upon 2R or 2 upon R, from where we get RP is equal to R by 2. So this is solution to first part. Now consider figure number 2. So in figure number 2, here the current through this resistor will be same as current through this resistor. Current through this resistor will be same as current through this resistor. So what do? We take this point O upside and we write the circuit as follows. So this would be R and this is R. Here this is R, and these two points, like this is R, this is R, and we write it up. Similarly, this point is O. The same point we write here. This is R, this is R. So here in between, there is resistance. This is R and this is R. Now, this point does not touch this wire, and this is also separate. So these two points are joined here, and the same is true here. This is small r, and then there is one resistance R here and one resistance R here. Now, these two are in series in parallel with this R. So we can find the equivalent of this portion, 1 upon R plus 1 upon 2R. So this will give 2R. So this is 2 plus 1. So this is 1 upon RP. So RP will be 2R by 3. So this portion will be replaced by 2R by 3. So circuit will become, this is R, these two, and then this is R. This portion will be replaced by 3R by, this is 3 by 2R, 2R by 3. So this becomes 2R by 3. And here also, this will be 2R by 3. This resistance is this, then this portion becomes 2R by 3, and then this resistance is written like, so let's rewrite it because there is slight confusion. So here, this is R, and this from here, RP will be 2R by 3. So this is R in series with 2R by 3. So this is R, then 2R by 3, then this resistance is R. And here, in between, this is R, this is also R. And then this one, this is small r, then this becomes 2R by 3. And then this is R. Now we find equivalent of each row. So this is R plus 2R by 3 will give 8R by 3. So this will become 8R by 3, and in between it will be 2R, and here this will also be 8R by 3. Now, these three resistances are in parallel. So we find our equivalent will be equal to, first one will become 3 upon 8R, second one will become 1 upon 2R, plus this will become 3 upon 8R. We take LCM, LCM will be 8R, then 3 plus this will become 4 plus 3, 6, 4, 10. So this will be 10 upon 8R. So R equivalent between points A and B will be equal to 8R divided by 10. R, it becomes 4R by 5. So this is our answer. Here, all that we do, we just take this point upward and this point downward, and then we analyze. Now, question number 42. Find the current measured by the ammeter in the circuit shown. So here, if we consider this portion, this, so here this 50 ohm resistance will be redundant, or we can remove it. The same is true here, there is symmetry, so no current will flow through this resistor. So this 50 ohm resistor can also be removed. So circuit will be like this. This is 10 ohm, and then in series with another 10 ohm, then this one will be 10 ohm, and then again this is 10 ohm, this is 10 ohm, and then this is also 10 ohm. So, and there is 6 volt battery here. So this is 30 ohm, 30 ohm. So 30 ohm, 30 ohm are in parallel. So equivalent will be 15 ohm. So circuit will be like this. So this resistance will be 15 ohm, and this is 6 volt battery. So we can find the current. So I will be measured by ammeter here. So I will be equal to 6 by 15, and this will give 0.4 ampere. Now let's go to next question. Question number 43. Consider the circuit shown figure X. This circuit. Find the current in the circuit and the potential drop across 5 ohm resistor. We have to find out PD across this. And the potential drop across 10 ohm resistor. Here also we have to find out PD. Then the same we have to calculate in this figure. So let's consider first figure. So here, if we apply KVL, figure X. So total voltage will be 6 volt plus 12 volt. So that will be, we have to find out I, suppose this is I. So I will be equal to 18 volt divided by total resistance will be 15. So this will become 36035. So this will give 1.2 ampere current. Now, if we find PD across this, so PD across, suppose this is V1 and this is V2. So let's find V1. V1 will be equal to I times 5. So I times 5. So I is 1.2 into 5. That is 6 volt. And V2, PD across this will be I times 10. So this will be equal to 1.2 into 10. So that is 12 volt. Now, if we consider this figure, here again, same thing. Total voltage will be 18 volt and total resistance is 15 ohm. So I will be 18 by 15, that is 1.2 ampere. Now, if we find PD across this, so it is suppose V1, this is suppose V2. So V1 will be equal to 5 into 1.2, that is 6 volt, and the V2 plus this. So V2 will be 1.2 into 10, that is 12. This is our answer. Thank you for watching.